Welcome back to ajspeller.com. In today's tutorial, we're going to solve this related rates problem. A 25-foot ladder is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. Find the rate at which the perimeter of the triangle created between the ladder, wall, and ground is changing when the base of the ladder is 7 feet, 15 feet, and 24 feet from the wall. Here we have some given information. Where x is 7, that's going to be our first snapshot. Using the Pythagorean theorem, we figured out that y was 24. dx dt of 2 feet per second is given. And dy dt, again, was found in a previous tutorial. And I'll add the link here. So what we're going to do first is we're going to label our triangle here. We know that the length of the ladder is 25. Whoops. The length of the ladder here is 25. We're going to label the ground here x. We're going to label the wall y. And we're asked to find the perimeter. Well, we know the perimeter is the distance around an object. So here we're going to say the perimeter is equal to the x value plus the y value plus the length of the ladder, which we know is 25. And to find out what the rates are, we need to take the derivative, the implicit derivative with respect to time. So here we have dp dt is equal to, well, the derivative of x is just 1, but we're taking the derivative with respect to time. So this here has a factor of dy dt. For the same reason, we have a factor of, dx dt. For the same reason, we have a factor of dy dt. And the derivative of a constant is 0. So now we can go ahead and do our substitutions to solve for this problem. So we have dp dt, or the change in perimeter over time. We're going to substitute in dx dt, which we see here as 2. And again, that's feet per second, plus dy dt, which is negative 7/12 feet per second. All right, before we can add these, let's go ahead and create common denominator. Well, this 2 was understood to be over 1, so if I multiply the 1 times 12, then that means I have to multiply the 2 times 12 to get 24. So I have 24 feet per second. And then I have a positive and a negative, which makes this a negative 7/12 feet per second. And then when I go to add these, we see that 24 minus 7 leaves me with 17/12 feet per second. So at the moment that the bottom of the ladder is 7 feet away from this wall, the perimeter is changing at a rate of 17/12 feet per second. All right, let's move on to our next example. All right, in our next example, we want to find the perimeter when the bottom of the ladder is 15 feet from the wall. And again, we have given information we calculated, and I'll add that previous tutorial. So again, the ground is going to be x, the wall is y, and the length of the ladder is constant at 25. So we want the perimeter, which is going to be the x value plus the y value plus 25. And we take the derivative. So here we have dp dt is equal to dx dt plus dy dt, and the derivative of a constant is 0. So here dx dt we know is 2 plus dy dt. dy dt is the negative 3/2. Again, I'm leaving off the units to go a little bit faster. I want a common denominator of 2. So this here becomes 4/2. And this is going to be minus 3/2, which is going to turn into a 1/2 foot per second. So at the moment, the base of the ladder is 15 feet from the wall. We know the perimeter is changing at a rate of a 1/2 foot per second. And now let's work on our last example. Again, we're going to label our sides. The ground is x, the wall is y, and the length of the ladder is 25. We want to find the rate at which the perimeter is changing when the bottom of the ladder is 24 feet away from the wall, and we have our rates here. So again, perimeter is equal to the x value plus the y value plus 25. We take the derivative with respect to time. So dp dt is equal to dx dt plus dy dt plus 0. Again, we don't have to write the 0 because we're adding. dx dt we know is 2. dy dt is the negative 48 sevenths. Let's get a common denominator of 7. So what I do is I end up multiplying 1 times 7 to get 7. So 2 times 7 to get 14. So now I have 14 minus 48 sevenths. And let's go ahead and do this here. I know it's going to be negative because the negatives with the larger number here. So I've got 48 minus 14. 8 minus 4 is 4, and 4 minus 1 is 3. So this here is really negative 34 sevenths feet per second. All right, and we know that at the moment the bottom of the ladder is 24 feet from the wall. We just calculated that the perimeter is changing by negative 34 sevenths feet per second. All right, that sums up this tutorial by ajspeller.com, and as always, thank you for watching.